So, Pew Pew, my friends. Pew Pew. The flying alien ship 3IR Atlas is moving through the whole solar system along a trajectory calculated back in June, and it's not even sweating. Sometimes its coma turns out larger than it should be, sometimes smaller, that its color is redder, then blur again, minor details there. There's black smoke coming from the smokestack, which means our train of attention is leaving the platform of past delusions and heading toward the shining terminal of new knowledge. Let's gather some scientific data about what was known, at least as of the start of September 2025, when this script is being written. We begin with a remarkable photo taken by Hubble on July 21st, which clearly shows both a drop-shaped gas dust coma and a tail already beginning to form. In the paper by David Jurett and others, based on Hubble data, it stated that the radius of the nucleus, determined from the surface brightness profile, must be around 2.8 kilometers, assuming absolute magnitude less than 15.4 and a presumed geometric albedo of 0.04, although it is likely much smaller. But Santana Rositol in July estimated the body's radius from purely photometric observations from Earth, and that estimate was a maximum of 11 kilometers, about twice as large under dust ejection speed from the surface between 0.3 and 4.2 kilograms per second. By the end of August, refined Hubble observations narrowed the range to between 320 meters and 5.6 kilometers. The tail. The optical scattering cross-section of 3IR Atlas is determined by dust ejected toward the Sun, while a weaker tail of length 56,400 kilometers pointing away from the Sun is formed by the pressure of its radiation. There are no signs of a narrow trail along the projection of the orbit, which would be produced by a prolonged ejection of large, slow particles. Mass loss rates in the form of dust are between 6 and 60 kilograms per second. The dust ejection speed toward the Sun is up to 220 meters per second, and perpendicular to the orbital plane up to 75 meters per second. Zishishin and colleagues studied the coma with the Swift Space Telescope and found that at the object's distance of 3.51 astronomical units from the Sun, the base dust output was 40 kilograms per second. Such mass loss of this order can be accounted for by equilibrium sublimation of relatively small patches of exposed ice of water, carbon dioxide or carbon monoxide. The carbon monoxide gas sublimation rate is 130 kilograms per second, water 6.6 kilograms per second, carbon monoxide 14 kilograms per second. By inferring the minimum possible nucleus radius using a model of equilibrium coma formation by sublimation, for carbon monoxide, one gets half a kilometer, for the less volatile carbon dioxide ice up to 0.73 kilometers, and for the least volatile water ice up to 2.5 kilometers. According to Webb and the NIR-SPEC spectrograph in a paper by Martin Cordiner and others, in the chemical composition of the coma the dominant gas is carbon dioxide, about 8 times more abundant than water. And in a preprint article published August 26, following Sphere and Hubble observations, researchers using the James Webb Space Telescope found an unexpectedly high concentration of water molecules and water ice, carbon dioxide and carbon monoxide gases, as well as carbonyl sulfide. By that moment the coma had expanded to about 348,000 kilometers. On August 30th, from Exuta spectra observations on the VLT, a paper was published reporting strong nickel lines at 3,414.8 and 3,524.5 angstrom, and also the cyanide radical line at wavelength 3,880 angstrom, whereas iron lines have not yet been detected. Though some other scientists suppose iron will appear when the comet gets closer to the Sun. The comet's nucleus rotates with a period of about 16 hours, increasing dust emission, current values between 0.3 and 4.2 kilograms per second, and its color reddens, not from shame, but from the appearance of a large amount of dust in the coma along our line of sight. On September 3rd, a team of scientists from the Southwest Research Institute led by Dr. Stern published a proposal for creating and launching a dedicated spacecraft to intercept 3IR Atlas. The spacecraft, named Comet Interceptor Pathfinder, could fly close to 3I Atlas and take high-resolution images, measure its composition, structure, and behavior. The idea involves using a gravity assist maneuver at Venus to catch up with the object. To do that, a launch would be needed within a year. In that scenario, a flyby at less than 1,000 kilometers from the nucleus might be possible. Good idea, but who will take it up? Who will finance it? I believe a mission like that makes sense as a standby craft placed at a Lagrange point, from which it could intercept future interstellar guests. But right now it's unlikely due to organizational reasons. What about the speed of our visitor? Oh yes, it's really impressive. Upon entering our system, 3I Atlas moved at almost 60 kilometers per second relative to the Sun, which, if I'm not mistaken, is an absolute record for all objects ever observed in the solar system. Then it turned out that the TESS telescope had observed 3I Atlas even before its official discovery, as early as May 7, 2025, during 2 separate observing periods. Since TESS takes many 200-second exposures, by comparing them one can see how the object moves and changes its brightness. At that time, May 2025, 3I Atlas was at 6.35 astronomical units away, and by the end of the second observing period, June 2, 2025, it had moved inward to 5.47 astronomical units, increasing its brightness by about 1.5 times. It is anticipated that on October 26, 2025, 3I Atlas will make its closest approach to the Sun at 1.36 astronomical units, after which it will begin drifting away into the dark depths of interstellar space. And what about the Lalian ship that many voices on Twitter have already declared dangerous for our civilization? Nothing. It's Dr. Lub from Harvard stirring the waters. I don't know exactly what his motives are, but assuming they're selfless and for the sake of science, I think he wants to draw the attention of the scientific community to the phenomenon of interstellar guests, and perhaps broaden the discussion, create some positive scientific conflict around this phenomenon, not just to popularize astronomy but to examine certain aspects of it more thoroughly. In particular, in August, AVI put forward hypotheses. In the article, What Do We Know So Far About 3I Atlas?, he notes that SPHERX observed a flux at 1 micrometer, suggesting an effective size of nucleus, or dust cloud, up to 46 kilometers, significantly larger than previous interstellar objects like 2I Borisov. In a subsequent article, The Challenge of Measuring the Mass of 3I Atlas, he continues the line about a large nucleus or a dense dust cloud. As we've already seen from published articles, nucleus radius is being estimated now between 320 meters and 5.6 kilometers, much lower than the optimistic enthusiast Lub suggested. In a collaborative work with Adam Hibberd and Adam Crowell, published in early August, Lub proposes using the Juno spacecraft to intercept 3I Atlas near Jupiter via Oberth maneuver. They show that with 2.68 kilometers per second one could achieve a flyby to 27 million kilometers using only about 5% of Juno's fuel budget. Good idea, for sure, but I doubt it will gain traction at the Jet Propulsion Laboratory with much enthusiasm. The mission's cost is high. Juno cost $700 million in 2003, which now amounts to nearly $1.2 billion, and it's primarily tuned for Jupiter observations, though I note some of its instruments could help with coma chemistry observations. But it likely won't happen. Lub also introduced a new classification scale, the Lub scale, Interstellar Object Significance Scale, an expansion of the Torino scale for interstellar objects. This scale, from 0 to 10, is meant to standardize the assessment of how anomalous an object is and to what extent technological origin is possible. For 3I Atlas it's given level 4, meaning there are interesting deviations, but no clear signs of artificiality yet. In the wave of hype, Lub was invited to mainstream media interviews in the Daily Beast, where he reiterated that the remarkable trajectory of the body, within 5 degrees of the ecliptic plane, with nearly close passes to 3 major solar system planets, Venus, Mars, and Jupiter, is most consistent with what an interstellar intelligent probe might do when searching for life in a planetary system. And in New York Post, Loeb claimed that the coma of the comet emits carbon dioxide so strongly that hydrogen losses are only 5% of carbon dioxide, a ratio 16 times higher than typical. Moreover, the absence of sharp tail and a size comparable to known objects has been asserted to suggest possibility of artificial origin. Well, they've revised that estimate down by a factor of 2, down to -8, and the comet has now developed a tail, however small. As for how other scientists have responded, the reaction to AVI Loeb's August statements has so far been cautious but attentive. Most astronomers emphasize that the hypothesis of an artificial origin is not supported by observation data, including chemical composition and dynamics. Still, some scientists find the Loeb scale idea useful in systematically evaluating interstellar anomalies. Overall, Loeb is seen as a provocateur in scientific discourse. His ideas are criticized, but can't be ignored. NASA, based on all the observations done, has definitively rejected the hypothesis of artificial origin for 3I Atlas. As you see, nothing surprising so far, except perhaps for the strong nickel lines, which by themselves, without iron, don't appear under normal cometary composition, and iron hasn't been seen yet, still waiting. In general, the level of alarmism stirred up through Twitter, public pages and quasi-scientific, or non-scientific, media was, say, somewhat exaggerated. As we said in previous videos and articles. And for the future, if you're being bombarded with messages like "go to sleep quickly, get your pillow," you should know you're being manipulated, even if not physically, then morally or intellectually. People think poorly when emotional. And the more emotion, the worse the thinking. Take a breath, count to 10, reread The Marriage of Figaro. You'll understand that everything happening isn't random. Until October 19, 2017, when the first interstellar guest, Oumuamua, invaded the outer parts of the solar system, we considered such events rare and interesting mainly for a narrow group of specialists, because our instruments weren't powerful enough. But new telescopes and observatories keep coming online. Together with powerful AI algorithms designed to find something unusual in the torrent of data they generate, even the faintest objects inside and beyond the solar system are now being found much more effectively. And we should be mentally prepared that very soon a torrent of discoveries we could never have imagined will wash over us. Usually I'm a pessimist, or realist if you prefer, but in this case I feel a profound awe at the power of modern astronomical technology, and I'm extremely optimistic. But will there be enough people to analyze all this flood of data and write serious papers? I don't know, but I want to hope for the best. Go for it, folks! Maybe your name will soon grace the new digital sky of the dawn of human knowledge about this ever-changing, living universe. There's enough sky out there for all of us. And maybe even a little left for aliens with their ships.